Friends, today you are going to learn the topic between relation between electric field E and electric potential. You know what is electric field and you also know what is electric potential. We are going to find the difference between electric field and electric potential. For understanding this, the relation, we need a source charge. Let us have a source charge Q here. The Q is a source charge, okay? Now Q is a source charge. From this source charge we take a distance. Let the distance is R. Then this point is A, this point is B. Let this point is B. Let us bring a test charge from A to B. R is the distance from this O to A is the distance R, and we are bringing a test charge Q naught from A to B. Then the distance from A to B is dr. Dr is the distance from A to B. Distance from A to B is dr. Let us have the distance. This source charge produces an electric field which is move outside because this is a plus charge. So this is the electric field along this side. E is the electric field. You know that electric field E equals to F upon Q naught. So force F is equals to Q naught E. This means that the force experienced by this charge is Q naught E. Force experienced by this charge at this point by this charge is F, which is equals to Q naught E. This is the force experience, and direction is along the electric field. This is the direction. We are moving this test charge from A to B, so direction of dr is along this side. So these are the directions. Since we are moving a charge Q naught from point A to point B, so we have to do some work. The small work done in bringing the charge Q naught from A to B is dw, and dw work is equals to F dot dr. In diagram, we have written F equals to Q naught E. So write this, F is equals to Q naught E dot dr. Now Q naught will be moved this side. So this is dw by Q naught is equals to E dot dr. You know that V potential, dV small potential will be dw by Q naught. So you know that V is equals to W by Q naught. So dV is equals to dW by Q naught, small potential. So at the place of dW by Q naught, we write dV small potential, which is equals to E dot dr. E dot dr. Or you can also write this, delta V is equals to E dot delta R. This is the relation for electric potential and electric field. We are going to further solve the equations. Since in the diagram you are saying that here dr and F are in opposite direction, they are anti-parallel. So the angle between electric field E and dr is 180 degree in this diagram. So in diagram, angle between electric field and dr is equals is theta is equals to 180 degree. Therefore dv equals to E dr E dot dr, which is equals to E dr cos 180 degree, and cos 180 is equals to minus 1. So this is E dr minus 1 here. So you have E is equals to minus dv upon dr. This thus electric field is equals to minus dv upon dr. V stand for potential and R stand for distance. Potential upon distance is said to be potential gradient. Potential divided by distance is said to be potential gradient. Potential gradient. and here we have a minus sign, so you can give a minus sign also here. So electric field is equals to negative of potential gradient. If you take the magnitude of this, then minus sign will be eliminated. If you take magnitude, taking magnitude, you write E equals to dV upon dr. So this is the magnitude, or this is also equals to delta V upon delta R. You can use delta in the case of D. This is further equals to V2 minus V1 divided by R2 minus R1. If V1 equals to 0 and R1 also equals to 0, from origin we are starting and potential at origin is 0, and V2 equals to V and R2 equals to R, position vector and potential, V2 equals to V and R2 equals to R, then electric field E equals to V upon R. It is a very simple equation. So electric field equals to negative of potential gradient. You have learned the relation between electric field and electric potential. Now let us see a numerical based on this. Numerical based on this. A numerical, I am framing a numerical. For this numerical, we have a source charge Q. You don't know what is the value of the source charge. You don't know what is the value of the source charge. Let us take a distance R. R is the distance, we don't know the value of R, it is also not given, Q is also not given, but here the value of electric field is equals to 20 Newton per Coulomb is given, and here at the same point value of potential is given, which is equals to 10 Joule per Coulomb. Then you have to find the value of source charge and the value of distance. For this we know that electric field E equals to V upon R. Electric field equals to potential gradient. So R is equals to V upon E. What is the value of V? The value of V is 10 here. And what is the value of E? It is 20 in the question. So it is equals to half. It is equals to 0.5 meter. So you got the value of R. This is the part A. Part B, you have to find Q. So you know that V potential equals to KQ upon R. From here you can write Q is equals to VR upon K. Now substitutes the value of V. V is equals to 10. R just you have find 0.5. And the value of K is 9 into 10 to the power 9. So this is equals to 5 upon 9 into 10 to the power minus 9 Coulomb, which can be written as 0.55 10 to the power minus 9 Coulomb. 10 to the power minus 9 means nano. So you can write 0.55 nano Coulomb. Thus, you have understand relation between electric field and electric potential and how to solve numerical based on this. Do like, share and subscribe my channel. Thank you.